Hello friends, how are you? I hope everyone is doing great. So in this video, I will discuss what microservices are and what are the advantages and the challenges that often arise during implementation. I will also share how to overcome these challenges by applying best practices and using key tools and frameworks here. And apart from this, I will explore practical examples here, including Eureka server for service discovery, API gateway for request routing, and Spring Cloud config server for centralized configuration management, and Jupyter for distributed tracing, and Resilience 4G for fault tolerance. Okay, so these are the things I'm going to cover in this video. So before I'm going to jump into these examples, I would like to discuss what are the microservices are here. And so microservices are it's known as microservices architecture. So it is an architectural style that structures an application as a collection of small and loosely coupled and independently deployable services here. And each microservices is focused on specific business functionality and can communicate with other microservices through a well-defined APIs. Okay, so often over HTTP REST or messaging queues. And what are the advantages of microservices here? So microservices are independently developed and deployable and scalable. So let's say that you have a couple of microservices. Failures in one microservice don't affect the entire system here, so that will improve the overall reliability here. And so here the teams can choose the best technologies. So here we have a multi-technology support. So teams can choose the best technology for each services here, and that will enable the innovation and optimization here. And microservices will align well with DevOps here, so that will facilitate the continuous integration and deployment here. Okay, and so what are the challenges we will face while we implementing these microservices, and how overcome these microservices by following best practices here. So first, complexity in service management. So what is the challenge basically? So if we are speaking about challenge here, so managing numerous services can lead to a significant complexity here. So especially in terms of dependencies and communication here. Okay, so in that case, the best practices are you can use Eureka server for service management in microservices architecture. Okay, and apart from this Eureka server, so you can use service mesh here. Okay, service mesh. So we have a couple of service meshes. So you can use Istio. Okay, Istio as a service mesh for centralized management of service communication. Okay, and apart from this, you can use the Kubernetes for orchestration as well. So this is you can overcome this challenge. And the next one is data management and consistency. So if we're speaking about challenge here, so maintaining data consistency across distributed services is difficult without traditional ACID transactions, right? So if you're speaking about data consistency here, right? So the best practice is we can implement event-driven architecture and sagas for managing distributed transactions and achieving eventual consistency here. Okay, so and next one is network latency and reliability. So network latency and reliability. So if we're speaking about challenge here, so inter-service communication over the network introduces a latency and potential points of failure. So here we can implement the circuit breakers and retrace mechanism to handle the failures gracefully and reduce the latency impact here. And security concerns. So if you are having a number of microservices, a larger attack surface with multiple exposed services increases the security risk here. So what we can do is by following this best practice, so that adopt zero trust security principles and enforce strong API gateway policies for authentication and authorization, so we can achieve this. And operational overhead. So what is the challenge here? So microservices require more infrastructure, and that will leading to increase the operational complexity here. Okay, so in this case we can automate the deployment with CI/CD pipelines and use the infrastructure as a code here. So for example, if you are here about Terraform, so Terraform by using the Terraform we can manage the infrastructure efficiently here. So Terraform, if you define like some script in the Terraform, so that will take care of like how to create the resources, and so this Terraform will maintain the state of the resources as well. And so this is the overall architecture of microservices. Okay, and so I'm going to cover all these examples in this video. Okay, so so let's say that whenever the request will comes before reaching to our microservices, how this API gateway will handle that request. Okay, so here an API gateway acts as a single entry point, okay, for all the clients into a microservices based applications here. So it routes a request to appropriate microservices, okay, handles cross-cutting concerns like security, logging, and rate limiting, and also like simplifies the client side code by providing a unified interface here. Okay, so here I am taking like Spring Cloud API Gateway. So apart from this, we have a Joule as well. So you can use Joule API Gateway as well. And the next one is Eureka Server. Okay, so what is the Eureka Server here? So Eureka Server is a service registry that is developed by a Netflix as part of the Spring Cloud Netflix suite. Okay, so it is used for like service discovery, and that will allow the microservices to find and communicate with each other, okay, without hard coding their network locations. So if you're speaking about like how this Eureka server will work, so microservices register themselves, okay, with Eureka server when they start up basically. So providing their details such as a host name and IP address and the port. So let's say that other microservices can query the Eureka server here and to discover the instances of the registered services, so which will allows them to call the other services dynamically. So the advantage is so dynamic scaling. So supports like dynamic scaling as a services can register and deregister automatically. Okay, this is the advantage of using Eureka server. And apart from this Eureka server, we have a Spring Cloud Config server. Okay, so Spring Cloud Config server is a centralized external configuration management tool for like distributed system. Okay, it provides like server side and client side support for like storing and serving the configuration files for the microservices. So how it will works is basically centralized configuration. I think you people may heard about Git repository, right? So it will stores the configuration properties in a centralized location, that is GitHub repository, Git repository, so which can be accessed by all the microservices. Okay, so if you are speaking about like how this dynamic update will work is like services can refresh their configuration without restarting. Okay, so let's say that you have defined like your configuration properties in a Git repository. So you can like refresh this configurations without restarting any microservices. Okay, so that will allow the dynamic updates to their application behavior basically. Okay, and apart from this, we have a Spring Cloud Bus here, and Spring Cloud Bus basically links the nodes of a distributed systems with a lightweight message brokers like RabbitMQ or like Kafka here. So here I have implemented Kafka, but I have mentioned the RabbitMQ, so you can use like depends on your requirement. So here basically it's used to propagate the state changes, configuration changes across a cluster of microservices. Let's say that here we have a 3 instances of the microservices, right? So here, so with the Spring Cloud config server, there is a one refresh endpoint. So with the help of that, you can refresh only single instance. So here with the Spring Cloud Bus, okay, so Spring Cloud config server basically it will refresh like all the microservices instances in a cluster here. So that is a difference. So there is a Spring Cloud refresh event. So by using that, you can refresh like all the instances of the services here. So I will explain like while we implementing this Spring Cloud Bus here. And apart from this, we have a circuit breaker. Okay, so what is a circuit breaker? A circuit breaker is a design pattern that is used to prevent a cascading failures in a microservices architecture here. Okay, so basically it stops the flow of requests to failing a services to allow it to recover or like to provide a fallback options, right? So here we have like couple of options. We have a closed state and open state and half open state. So I will explain more while I am implementing this resilience 4j with this circuit breaker. Okay, so till that time, let's go into the next one. So Spring Cloud Load Balancer. So what is Spring Cloud Load Balancer here? Spring Cloud Load Balancer is a client-side load balancer that distributes incoming traffic. Okay, incoming incoming network traffic across multiple instances of the services. Okay, to ensure the reliability and availability. So client-side load balancing, basically this Spring Cloud Load Balancer will support like client-side load balancing. So that will basically requests are distributed from the client's perspective. So often using round robin, we have a random and other strategies as well. So we can make use that these algorithms. And so with the help of that, so basically balances the load across the multiple services instances to handle the higher traffic basically. Okay, and next one is like Zipkin, distributed tracing using Zipkin here. So distributed tracing is a technique that is used to monitor and troubleshoot, okay, microservices architecture by tracking the request as they flow through the different services here, right? So whenever the request will comes here, so if you want to tracking the request as they flow through the different services here, right? So then we can go for like distributed tracing using this Zipkin here. Okay, so in the Zipkin we have a different kinds of states. We have a tracing, visualization, and troubleshooting. So I will explain more while I am implementing this. And so the benefit is, so provides a deep insights into like how services interact and where delays occurs. Okay, so we can find out by using this Zipkin as well. And apart from this, I have provided like some of the monitoring and ELK stack and databases and Swagger documentation. So monitoring, so we can implement Prometheus and Grafana to monitor this microservices. Okay, and apart from this, we have a ELK stack. So basically ELK stack is consists of 3 open source tools like Elasticsearch, Logstash, and Kibana, that is used for like centralized logging, log analysis, and visualization. Okay, and at databases, you can choose like one service for database or like multiple databases for like multiple services here. And apart from this, Swagger documentation. Okay, so this is how the overall architecture will look like. And so I'm going to cover this all the examples here. Okay, so yeah, let's jump into the code without getting any delay.